So, log number 5, and for this one we're going to add some unit movement using the A-star pathfinding algorithm. The previous video I did was the precursor to this, so let's get started. So what we need to do is we need to update our player system. So where we do nothing here, we're actually going to we're going to change this to take a series of steps instead of a direction. We used to take a direction, and this was just for testing purposes. We're going to take a series of steps here, which is a vector of coordinates, because we'll get these back from the A-star pathfinding function that we'll be calling later. So we're going to change the direction to steps, which doesn't exist. So we're going to go and change that now. Steps, and then we'll have a vec, and we don't need any of this stuff really. Let's see, what else do we have? Okay, so that changes everything to steps. Let's go and fix all the arrows we have now, and that can just be a vec. There we go. Okay, so that's fixed our game world. So we're gonna go back to player and actually implement this. So we have to deal with 3 different things here. We have to deal with the player reaching the step, the player almost reaching the step, and the player not reaching the step. Okay, and that's gonna make sense in a second. So we need to make this writable, which means this has to be mutable. And let's see, so we're gonna take with if some step equals steps 0 first. If we have a step, otherwise we won't really have to do anything. So we can compare the step to the player's current location. Player pos is player dot global position. And if the step is equal to the player position, then we can remove that step and continue. And let's say, so that is okay. So reference, let's do this. Okay, and the next thing we're going to do is we're going to check if the distance, we're going to add some distance. If distance is less than 2.5, that's just an arbitrary number. And the distance is the step minus the current player position length. That's our distance. So the reason we do this is because you might end up being very close to being on the position, but not quite, and because depending on how high the velocity is, you might never reach that point. So the player basically just vibrates for a bit. I'll say the player, the unit just stands there shaking around for a bit. So we add this. It's like a margin for given that, whoops, given this, we probably don't even need this. Come to think of it. No, you know what? We're going to take that out. We'll take that out for now. We don't need that. And then now we've got to do the actual player movement. So move and slide. And we need a velocity, which is we're going to normalize the step minus the player position to get the direction. And then we're going to multiply that by a speed value. And we say that that's 100 something, right? We don't know what the speed's gonna be, and it probably won't be declared in a variable here every time. So velocity. Okay, that's it. This is gonna fail because there is no move and slide on the player object. So let's go and add that. Let's see, we'll add it down here. It doesn't have to be public. Move and whoops. Move and slide. We need the velocity, and we're gonna call self.0.move and slide default velocity with a 0 up vector. There we go. And to do that, we need to use movement, move 2D. So I made a move and slide default for kinematic body. So these are just the default values that that you can find in the Godot documentation. But rather than putting all this in every single time, I just did this move and the slide default. It just makes it a little bit easier. And that should be it. Okay, and that's building and that works. All right, so next up, I'm going to go and add the actual pathfinding. Okay, it's time to add the actual pathfinding. So we can see how the pathfinding is applied to here. We'll call a star search with a start point, which is an index, and an end point, also an index. And if it is successful, we can do something with steps. So let's do that. Let's see what we got. We got mouse event. There we go. Okay, so if the mouse button is pressed, then we are going to get the mouse position for that. But before we can do any of that, we need to actually have the map in here now that we made yesterday. And we also need to have tile map from Godot. And that should be up there. So our game world should now have a map. But we can't get the map until the node is ready. So we're going to make an option map. And let's add that here as a none, and on ready we can say first we're gonna get the tile map, and that needs to be mutable because for some reason getting the world the used rect function needs it to be mutable. Tile map is owner.get and cast tile map, and in Godot I call this path map because this is responsible for, you know, drawing terrain where the player can walk, right? So we're gonna do that, and we're gonna unwrap this because we can't continue if there is no path map. Actually, what we can do instead of doing that, we can use the GD extras sum or bail. Right, and what this lets us do is called sum or bail, and if we can't get that, so fail to get tile map. So this will print fail to get tile map along with 94, which is the line number. I'm pointing at my screen. 94, which is the line number, and the file name, which is gameworld.rs. So it's quite handy, so we can see where something has gone horribly wrong. There's no get and cast. That's because we don't have that here. Node extension. There we go. So then we can say let self dot map, which means self needs to be mutable. And let's see, self dot map is equal to, and we're gonna have to do some unsafe bits here. Tile map dot get used cells, and that needs to be converted into vector 2 because it's actually a variant array. So we can collect this. We don't know the type. This will give us a an error, but we're going to know the type once we call map new, and that takes the cause, map size, and tile size. So cells, map size, and tile size. Tile map.get used rect, and tile size is tile map.get cell size. There we go. So we return the map new, and that has to be sum. There we go. So now we have a timer. Okay, I thought we'd have a timer. Hang on. Okay. Oh. Right, let's pretend I didn't just do that. And let's move on to our event. Okay, so the first thing we're going to do is we have to get the mouse position, convert mouse position to index. That's our start. Here, this is the start point. And then we have to get the player position, and then we have to convert that to an index. Okay, and we can only get the player position if we do this with world. So we need the player. Let's see if we have the player here. We got the player there, but what we don't have is selected. Okay, we are only interested in the selected players, so we need that in there. So let's say for player, which is read only, we're only going to read the position, but we are going to modify the steps. So the steps needs to be mutable. Play steps in, and then I will read player and a write steps. Query, and then filter on the selected tag it mutably world. Ooh, okay, that was a handful. So do we have the steps, and do we have we do have Legion, we have steps. Okay, but what we are missing is we are missing the bracket pathfinding. So we cannot call a star. Alright, we got selected. Let's see if this builds. Okay, great. So now we can get the start. So let's get the mouse position and convert it to an index. So that position, you know what we're gonna need? We're gonna need the tile map. If we don't have the tile map, then we cannot convert the mouse position and so on. So lat position equal tile map dot mouse position, get mouse position. Nope, not at all. Okay, what's that then? It's get mouse position. No. Oh, hang on. Unsafe. Right. Our unsafety friend is back. Unsafe and unsafe. Alright. And then we can do let's start. No, not let's start. Let goal equal. You know, we need the map as well. Let map equal sum or bail. Well, in this case we could just match self.map, and if we have, we need to take a ref, none, then we just return. Okay, maybe some or bail would have been better here. Whoops. Because it would show what line it is, but we know we're gonna have the map. If we don't get the map, that's because this didn't happen. Okay, so we got the map, so now we can do self.map, no, not self, anything. Map dot local position to index, and that's going to be our pos there. And that is private, so we need to go and make that public, and we are probably going to have to make this public as well, and we're going to move these. We'll put them, let's put them up here with the new function. Let's put all the public jazz up there. Right, and let's go back to our game world. Okay, that's fine. So we've done that part. Now we need to get the player position. So we can say player position equals player dot position. That needs to be global position. And then we're going to convert that to time map to local player position. You know what? Let's just do this. Player dot global position. I'm not going to need that anymore. Delete. Come on, delete to. There we go. Time map. Blue. Right. Okay. So we got the player position, and now we need to convert that to our index. So let's start equal map dot local position to index player position. Okay, so we got a start and an end and a map. So now we should be able to say path is equal to a star search with start, goal, and map. There we go. All right. Ooh, okay, hang on. That's already a reference. So what am I doing? Okay, now we can actually look at our path.steps. And can do that. But let's not bother with that. Okay, let's not bother with that. So we're going to say steps 0 is equal to path.step. And if success is false, that means that steps is just an empty vector, so we don't have to worry about checking that or such. So path.steps.iter map, and then we're going to take each step, and that's going to be a reference. So whatever, each step, and we're going to convert the step to global position. So tile map dot to global, and then map dot to local position to index to local position, dereference the step, and collect. Which that was not right at all. Okay, so what's it saying? Option. Okay, well, because we know that index to local position is going to be fine, we can unwrap that. How do we know that's going to be fine? Let me think about this for a second. So the steps we're getting, yes, because they've been checked through the maps available exits. So if there is no coordinate there, it's not a valid exit. So it's it would be nothing to unwrap there. I mean, this is really easy to miss, but in this case we have to do something. We have to do something with the step. We can't have an option in there. I mean, we could filter out steps that aren't valid or whatever, but that in itself just seems a bit wrong. Okay, so this is now working. This is now built. So let's go over to Godot and see if this works. Okay, let's go to our Godot directory. And let's run Godot. Come on, TSCN. Okay, so these tiles are pretty awful, and but you can see that they are tiles. And here's our player guy. And we click on that one. Hey, look at that. Okay, we can select him. And now he gets deselected when I click some. Well, we have to fix that. But we have a bigger problem on our hands, and that is what happens. Well, first of all, there's an island here that you cannot go to, so that means the pathfinding is working. We can only go to tiles that are available. You know, all right. Players should not collide with each other, and that was that's a rather interesting one. Players should not collide with each other, and the and let's see, this shouldn't work. Alright, okay, and I thought it might happen if we try to go outside of it. So what we're gonna do next is we're going to make sure the players don't collide with each other, and we're gonna fix that panic that we had there. Okay, so let's go and do that. Okay, so we're gonna go and fix that bug now. And we can do that by making sure that our public functions are actually returning a valid position. So here we call local position to index, but we just clicked anyway. So it's gonna say, all right, here's an index and go and use that. But that's not valid, right? This needs to be an option because this is an external input. We don't know where it's coming from. We don't know where the user clicked and so on and so forth. So let's make this into a usize. And then we can say if the, you know what, match get index, and if it's some occupied cell, then we can return the index. Any other outcome, return a none. Alright, and this should break a few things because we are doing this, and so start and goal are now options. So that's not great. So let's see, the start we can unwrap because the player is always going to be on the map. Well, okay, so far the player is on the map, but the goal on the other hand, that might not be. So let's match that one and say some, then sure, none, then we just return. And that's okay to do because if you're clicking somewhere else, then you know, just bail out of it. Okay, well that's building. Let's see if this works. All right, well let's go over to Godot. Okay, so we're gonna select the player, click up here where it broke, and it doesn't break anymore. Same thing down there. Okay, so that's now working. However, we have another problem. What if we try to put well, beside that, two players at the same one? Okay, so they are now colliding, and they shouldn't occupy the same space, but they could very well. There you go, that's the one I'm trying to show. Okay, so what we need to do is we need to figure out if you've selected multiple players, and if you click to move, then we can give the first player the final tile in the path, and then pop that, and then give the second player the next tile, and so on and so forth. So that should take care of that. All right, so let's go and do that. We have one thing that we have to fix that I did not think of, and it's the bit here. If you are moving a unit, it might not actually land in the middle of the tile, and that's what I want. So I'm going to change this to say player set position to the step as well. And there is no set position on the player, so let's go and add that. And then position. There we go. All right, so then of course unsafe. That way the player will definitely end up dead center of the tile. Let's go commit that. Okay, so now we need to add the we need to track the steps the player has already taken. So last, we need a mutable vector for last steps. And here we have all the steps. So we can say if steps 0.last, then if the last steps contains step, then we do this. If the last step contains the step, then we need to pop it. Otherwise, we can last steps dot push the last step and break from the while loop. Okay, so that should do it. So now if I select all player units and click somewhere, they should end up walking in line as opposed to trying to stand in the same tile together. So let's give that a whirl. Okay, so we got all our units selected and click somewhere, and they are all hanging out together now. But the collision detection, I've changed the collision detection for the units now, so they are, who knows what they're up to, but now they don't collide with each other, so he can sort of walk straight through this guy, which is fine. And yeah, so one of the reasons they might be showing this sort of erratic behavior is because of the pathfinding algorithm. So if we go and change that to a more expensive algorithm, they might stop doing that. So let's give that a try. Okay, so here we have our distance algorithm is set to Pythagoras squared, and I've opened up this the GitHub page for this, and we can see what we have. We have Pythagoras square, we have Pythagoras square, Manhattan, and Chebyshev. And I think Manhattan is probably you might be the cheapest one, but I think that's the most expensive one. So we can try the most expensive one and see how that works if they do the same thing. Select all units, click up there. Alright, that wasn't necessarily better. Not at all. I do wonder. Oh wow. Okay, I do wonder why they're doing this. Okay, I'm going to stop the video here, and I'm gonna try to figure out why they are moving around like that, and I'll resume once I figure that out. Thank you.